can escape from being swallowed.
Now, mathematically speaking, anything can become the celestial body if you were to compress it into a small enough space. That's right. You, me, this room, anything could potentially become a black hole. Everything in this universe has what is known as a Schwarzschild radius, a tiny amount of space that if you were to collapse the entire mass of the object into, its density would be so great and its gravitational pull so strong that it would form a black hole.
If you were to compress the entire Earth down to the size of a peanut, you would get a black hole. If you were to compress Mount Everest into something smaller than a nanometer, you would get a black hole.
Wait, how small is a nanometer?
Well, since you asked, the width of a single human hair is 80,000 nanometers across. The single strand of human DNA is approximately 2 nanometers across. Fortunately for us, there is no known way to compress Mount Everest or the Earth in that fashion.
But a star many times larger than our sun, has a much larger Schwarzschild radius. And when it runs out of fuel and can no longer keep itself hot enough, it collapses to a point smaller than a single atom, known as the singularity.
The singularity will have a density of millions of stars, so its gravitational pull will be so strong that nothing can escape, not even light. We now have a black hole.
Black holes are amazing feats of nature. They contain and exert such powerful forces. They help keep galaxies in one piece. And in the future, they just might be able to help us travel to different times, alternate universes, or stars and planets millions of light years away.
Wait, how is it possible to travel millions of light years away through a black hole?
Well, first of all, it's not possible. Yet. Today is only a theory. And second of all, black holes are only half of it. That other half includes a white hole and negative energy. All these things together results in a wormhole. Wormholes are predicted by Albert Einstein's theory of general relativity. And today, many experts in the field of general relativity and gravitation have and are doing lots of work on them, trying to prove whether they exist or not.
You may have heard of wormholes in TV shows like Star Trek or movies like Interstellar, because wormholes are very popular sci-fi ideas. But real scientists theorize that many black holes are connected to a white hole with a tunnel in between. White holes are like the exact opposite of a black hole. Instead of sucking up stuff like a vacuum, it spits stuff out. Scientists theorize that any matter sucked up by a black hole is spit out by a white hole millions of light years away in an alternate universe or back in time. The only way to find out if this is true is to throw something inside it, like a satellite that costs millions of dollars with cameras, or an astronaut.
But there are many problems. First, according to science and math, wormholes should exist, but in the real world, we have not yet found any legitimate evidence. And second, if they were real, wormholes would be extremely unstable. Anything that enters could cause the wormhole to collapse or close, causing your entrance to shut forever.
So how do we solve this problem?
Well, scientists hope that in the future, they can find a way to stabilize these theoretical wormholes with something called negative energy. A complicated concept used in physics that is way too complicated for me to understand, let alone explain to you guys today. But if we somehow are able to stabilize the wormhole with negative energy, we can turn the fantasy of warp drive into reality. In conclusion, black holes, white holes, and wormholes are some of the many amazing and most mysterious things in our universe.
When you learn about how powerful and strong they are, it makes you wonder how